Hi everyone, my name is Yakov Zhmurov. I'm UUI architect and product owner on a EPAM internal UI framework called UUI. Also welcome Alexey, our UUI development team lead.
Hello.
Okay. Do you see slides? Not yet. Yeah, great. So today we will talk about our EPAM front-end development library and accelerator. Why and how we developed it, highlight some features, challenges, and lessons learned. You can put your question into the stream chat, and we will try to answer them all after the tech talk. So UUI is a PAM front-end accelerator which consists of React-based UI component library, Figma library, and many other services around to help building front-end applications. It's widely used to develop EPAM internal applications as well as applications for EPAM customers. It's open source and it's free to use. Let me start with some background and history. The first time we used React and TypeScript at EPAM internal projects is back in 2013. Both React and TypeScript was just released back then, and we were among early adopters. Over the time, more projects were starting, and we used the same stack and started reusing our components. In 2019, we assigned a dedicated team to UUI, so it's kind of the birthday. Initially, the design and UX kit evolved in parallel, but later we merged it, and currently it's developed by the same team, and Figma and implementation is highly aligned. In 2021, we make UUI open source. This was done primarily to open UUI for projects for EPAM customers, and any proprietary license would be a showstopper. The same year, we get our first customer. Over the years, UUI gone through three major brand look and feel changes. As a result, we learned how to be customizable. So it was a long journey, and the current solution is packed with experience of building projects and adapting to changes. You might be using EPAM internal products like Learn Time, Vacation, and many more. They design and front end are built using UUI. These apps are a great demo of what UUI is capable of. So we have a rich set of components to build modern business applications. UI provides complex turnkey solutions for common UX patterns like data tables, data filters, various forms, and lists. UI also supports advanced editing experiences. A good example is the Learn Back Office. It includes a visual content builder, interactive course dashboard, timeline. So UUI is not limited to basic forms and tables. We build complex UX on top. UI is flexible, allowing to build custom UIs like this. Recently, we supported a new EPAM brand by introducing a new theme. And besides supporting EPAM brand, we also create custom themes for EPAM sub-brands. Now, let's talk about why we decided to build our own library instead of going something like MUI and design. So think about starting a new project. You might pick MUI, but before starting to use it, you have to build a theme for a client. Then you probably need to pick some third-party components that aren't included in the library. These components also need to be themed and integrated. You also need to pick and integrate many other pieces like choose a form state manager. Each of these steps leads to a collection of shared components, patterns, helpers, sitting somewhere in your /src/common folder. So even a simple single project would have its own mini framework. But if you have more than a single project, this repeats. Eventually, you start copying this code, reusing patterns from projects to projects. At some point, it becomes clear that you need a reusable library. So whether you plan it or not, you end up building some form of library to handle these necessities. Even if we initially choose MUI, UUI would have emerged naturally because our needs extend beyond just basic components. The question was never whether or not to have a library, but what parts to build ourselves versus what to take off the shelf. And yes, UUI include its own component implementations, which does not rely on any third-party library. Was it necessary to build our own set of buttons and inputs from scratch? In our case, we started when there was no good existing libraries. But in general, this choice largely depends on whether your design and product teams are ready to compromise. So it's not really a technical question. It's more on whether you want to save efforts or you want to have exactly what you want. Note that changing colors of existing library is not a big deal. Most libraries does support this. However, you might want different component sizes or have different variations of component or even different behavior and internal parts. Consider restyling this and deselect to match MUI or UUI1. And D doesn't even have an option to show checkboxes. So even adding checkboxes is kind of deep customization. Um, Adding things like show selected only like search might be even more difficult. So if you plan to customize components like this, it's might be cheaper to build them from scratch, or at least start with some non-styled component set. Over customizing existing library components can be a nightmare. In our case, building our components was expensive, but on our scale, it paid for itself. So UA has a good set of components, but in this talk, we won't focus on them much. We rather talk on what UUI has, which components libraries usually doesn't. Let's start with an example. We started a project and we need a select component to pick locations, like cities or countries from the tree. There are thousands of locations in your database, and we can't load them all to a browser. Luckily, we picked and design, and at least it has three select component. MUI doesn't even have it. You dive into the documentation and find out that lazy loading data is completely up to you. You store the currently loaded data in state. You handle unload data callback to like adjust the state and include the new data used. You manage the loading state, stuff like that. So it's does not look really scary, but when you deep like if you when you start needing more features like search, it quickly becomes more complicated. And this case actually is very common for our internal applications. Like most applications have kind of tree pickers or pickers with lazy loading. So we definitely need to save here by reusing this. And in UUI we do. So in UUI you can build location picker with the following code. So we create a configure the data source, which is the tool to handle lists of hierarchical data. Then in this case, we pass an API to it. It's just a synchronous function that takes like current search, range to fetch, and it needs to return loaded items. Then we pass this data source to the picker input, which is basically a supercharged select component. We also pass value and value change as this component is fully controlled. And in this case, we just use state to store currently selected items. And we pass some option like we want to select multiple items and we want to cascade selection. So it's done. Nothing more needed. So note that resulting component is way more feature rich and complex than even customized and diversion. There's a lazy loading for both parents and children. So if country happen to have thousands of cities, we won't load them all at once. We have rendering virtualization, there's selection cascading, search, show selection switch, stuff like that. So the first key feature of UUI I want to highlight is that we handle component behavior of such common use cases out of the box. Okay, I've talked about data sources. So we got a built-in state management for the select component. But the same code might exist in other third-party select components. But we have a library and we have other use cases for trees and lists. So we decided to extract this logic and reuse it to any kind of lists and trees. Data sources are also used to manage tables. Um, However, they are not tied to component. So you can build like custom trees with this, or even the whole screen e-commerce like experience with product catalog. Data sources can do a lot you might want to from the lists and trees. It's allows lazy loading, selection cascading, filtering, search and sorting, um, rendering virtualization, and also support editing. So we have visual components like tables. We have data sources to manage their state. And we add more utility on top, like the filter panel, which support common types of filters to like multi-select in this case, or preset panel when user can save pre-configured screen setup. All these parts can be used separately, but they are very simple to connect. Most of the code of the screen fits into one slide. So we use table state to store the state in URL. You can use plain use state as well. We configure data source pretty much like we did for the select component. Then we pass the state as well as callback to change it to filter panel, to preset panel, to table. So they are controlled component connected via the common state. Pretty much React way composition of different components. So our users can build such common screens fast, but they won't get stuck if they need to customize or evolve them. Yeah, also has a built-in support for forms with everything you expect from forms. Forms are handled with use form hook. This hook is pretty much like use state with a bunch of additional features like validation. We also have helpers for convenient and type-safe data binding. And there is a similar reuse approach for to what we do with data sources. So we use form not only for forms, but for example, editable tables. Another thing we feel we did well in UUI is extensibility. As I mentioned before, we have many reasons why we need to support customization. First, EPAM brand changes. Then there can be highly opinionated demand from a project which we don't want to implement in the library, but we can't reject. Customization also the key to keep UUI complexity under control. Instead of bringing some rarely used features into the library, we build customization APIs and we give user examples how to use them to achieve their goals. There are many ways to customize UI. There is a flexible themes system, which we'll cover later. All components allow putting CSS classes on them to tweak them with your styles. We use render props extensively, allowing to replace parts of components. On the right, I've highlighted replaceable parts of the picker component. We come with the following pattern for render props. When we introduce a render prop, we also export the component it renders by default. This allows to render the same part component as it does by default, but customize the props hooked into its callback or wrap it somehow. In the example here, we use this approach to add avatar and subtitle to the existing picker input row. We also have non-styled version of component, so you can reuse behavior but rebuild the visuals. There are settings object to tune various non-CSS things like wording to translate text in components. You can even add your own component variations like properties and extend component prop types. We know that our customization is good because we resolve a lot of requests for some uncommon features with customization, just by building a code sandbox example on top of existing customization APIs. And a good example how all these features work together is our project demo, available at uui.epam.com website. This demo uses forms to manage the state of the edited rows for UNDA, for cancel save, and so on. It also uses data sources for like folding, unfolding, search, stuff like that. And the screen is also a good example of customization and composability. Like we use the same input components as in cell editors. So you can drop like picker input, date picker, or plain text input into the cell, and it will be adjusted automatically to match like visuals. So the whole table header on the right and the cells on the right are replaced by our timeline component to show this Gantt chart. And we use drag and drop utilities to reorder table rows. So for sure, there are many hooks libraries that does similar things, but we does not see libraries with the same capabilities. On the other hand, there are very feature-rich table components, but their internal state is a black box, and it's hard to tweak and hard to reuse for other cases. I believe that we are able to achieve this level of integration and reuse because we have a relatively big library. So we have many use cases to work with, and we can build components and hooks in parallel and like adjust them to each other. Achieving the same level of reuse between separate libraries is possible, but would be just way harder. And two more interesting things. First, we have a rich text editor component. It is based on the open source plate.js library. And we built its UI like toolbars, buttons on UUI components, so they match the whole design and support themes. So we kind of deeply integrated it into the library. We work a lot with Plate.js team and contribute numerous fixes to them. Notably, we contribute cells merging logic into the table plugin. So it is a good example of collaboration. Another unusual thing is timeline component. It looks like a very niche component, but it's actually used by several projects, so we have it. We also have a lot of small things most projects need. We have error handling with standard splash screens. There is subsystem to display model windows, notifications. We have helpers to send events to Google Analytics or other analytics, drag and drop, and more. So just just a bunch of small things that you don't need to bother integrating yourself. So to sum up, as I shown, UUI is not just a component library. It's neither a framework in a common sense. For example, we don't force you to choose state management library or a build tool. UUI is rather a set of components and subsystems focused on our primary goal to help building UI faster and better. We try to not reinvent the wheel, and we build on top of existing libraries where possible. But we don't hesitate to build that we need if there is no good existing solution. Okay, for the next part, I give the floor to Alexey, UUI development lead. Alexey, please continue.
Hello, everyone, again. As Jakon mentioned earlier, UI has a wide range of components, from simple buttons to complex tables and even rich text editor. And one more big benefit of UI is that all of these components can be zemmed together according to any brand. This is different from our competitors, where even if you can zem basic components, you still have to struggle with zemming third-party elements like tables, forms, rich text editor, and others. Therefore, all UI components and parts come with powerful zemming and customization options, including colors, sizes, icons, to match the client brand look. Here you can see a few examples of already styled UI component in different zems. Let's look on it in a few seconds. Now let's see how zemming works under the hood. As a basis for it, we choose CSS variables since they are native CSS mechanism with good browser support. And we also wanted to avoid relying on third-party solutions like CSS and JS, which can be cumbersome and not suitable for some of our clients. And CSS variables turned out to be a very powerful solution, as we will see at next slides. The next step was to decide on approach for composing this set of variables. If we are looking at other UI libraries with zemming, we will often see one of two approaches. A small set of zem variables that allow you to quickly and easily create a new zem, but it leads to limited customization options. And another approach with large set of variables that offers wide customization possibilities, but often you have to specify all of them upfront, which requires you to deeply dive into the details and put a lot of efforts from scratch. In UI, we decided to take a middle ground between these two approaches, giving the flexibility to choose whether you want to go with simple approach or go deeper for more detailed adjustments. In our approach, we created 3 levels of abstraction, as we can see in the pyramid of this slide. First one, semantic colors, contains your brand colors. The next one, core variables, contains set of variables for different logical groups, like controls, surfaces, and others. And the biggest level, it is component-specific variables, variables for each specific component. Now let's go deeper and see how this CSS variables zemming works using the example of styling the border color for text input and checkbox component. Here we can see the part of text input CSS file. Here we have a border color property, which is defined using UI text input border CSS variable. This is component level variable, which get its value from core level variable UI control border, which also get its value from semantic level UI neutral color. And this UI neutral color also used not only to define UI control border, but also to define color for dividers, skeletons, and other parts. As we can see, the only one variable that takes exact color value and not get its value from other, it is neutral color. Here we have a hex. It is only one variable that is required to define upfront to make this case work. All other variables will inherit value from it according to defaults. But let's imagine that we need to use another color only for controls without affecting dividers and skeletons. Here we can't use neutral semantic color because it affects skeletons and dividers. So we go level deeper and override UI control border with your expected colors. For example, green. And in this case, you will receive that all controls will have a border green with green color, and divider and neutral will still use neutral. And let's see another case when we want to leave neutral color for all controls, but we only want to change the checkbox border, for example, with blue. So we go one more level deeper and change directly component-specific UI checkbox border variable. All other controls and parts will use neutral as it defines on core level. Okay, let's go back to our pyramid. As I said on the previous slide, the only one level of variables that must be defined upfront is the semantic core level. This is the smallest group of variables which is consist only expected brand colors. All other variables will inherit values from it according to our predefined defaults. If our defaults doesn't work for you, you can always go a level deeper and override values for core or component specific variables. This approach allows us to achieve several benefits. Quick start, as we don't need to define big amount of variables right from the beginning, and precise customization depends on your needs. Here, let's mention one more advantage of UUI. It is compatible design library, which match into dev implementation. This allows designers to build pages in Figma using pre-made components like we do it in React. This speeds up design implementation and keeps designers and developers in sync. In other case, we have such UI design library in Figma. Like the React library, it's also open source and available for everyone. And it also includes a Zemin system to configure components in Figma. To enable this, Zemin we create a set of Figma tokens used to define component appearance. It's something similar to CSS variables which we are using in React. Moreover, the core level of Figma variables is fully aligned with React implementation. This is essentially important during design dev communication, but it also allows us to write the script that generates CSS of them based off tokens exported from Figma. This makes start of front-end development almost effortless and reduce support costs. Side changes in Figma can be applied to the code with minimal developer effort. You just need to generate new CSS from Figma and upload it into your project. Okay, let's go further. Here I want to share some interesting details and approaches about how we're developing and maintaining our library. First of all, UUI is fully open source under Mint license, and everything lives on GitHub. That's where we do all of our development process too, using issues for our backlog and GitHub projects for managing tasks. UUI users can view the code, open an issue, ask a question, or even contribute. It is open to everyone. We use monorepo pattern, but each package is built separately when we do a release and then publish it to the public NPM. And also, it is easily to start with UI. By using our pre-made project templates for Vite, Create React App, or Next.js. Or for even faster start, just by opening a template on CodeSandbox for a quick demo. All these templates can be found at our documentation or GitHub page. Now let's talk about our documentation. In our development process, we follow the eat your own dog food principle, meaning we actively use our own components and tools for ourselves. Applying this approach, we built uui.epam.com site with detailed documentation, including comparative examples and descriptions for each component. This site is fully built using our UUI components. For example, we use our rich text editor to write the descriptions for examples. In addition to examples, we also have API reference section for each component and export it from package interface. What might be interesting is that we fully auto-generate this section using TypeScript compiler API to extract this data based on TypeScript interfaces with JSDoc comments. So you can find these descriptions for interfaces not only on our website, but also directly in your code editor when using UI components. Additionally, we have a property explorer feature for each component. This is a separate page that lists all components props and the possible variations of their values. So if you need to see how components will work with certain combination of props, you don't need to set up it in your code first. You can do this directly on the property explorer page, choose expected properties and copy the ready-made code from there. This feature is especially loved by our testers and developers as it greatly helps in reproducing bugs and testing components. Moreover, the Property Explorer block is also automatically generated from code as we have metadata based on TypeScript interface. Since both API and Property Explorer box is auto-generated, we not spend a lot of time for their support. Code changes automatically update documentation. Let's a little bit talk about our testing approaches. There we also have a few interesting things. In UI, we place significant efforts for testing coverage because any bug in the library immediately affects all projects that use this library. We have several types of tests. First one, and classical unit tests, and we also have snapshots. We have more than 70% of our code base covered with unit tests, and each component has snapshot tests that help us to track unexpected changes in component structure. While writing unit tests for ourselves, we often create various mocks, utilities, helpers, and other utils to make testing more convenient. And we also wanted to share them for our users. So we collect them into a separate NPM package and provide it for our users to facilitate writing tests for our components in their projects. Next type of testing, it is screenshots. Screenshots tests are often not suitable for regular projects because UI elements frequently change and they are highly dependent to each other. However, in our case, it is opposite. We have many atomic components that are low-code and changed not so often. So this allows us to create isolated screenshots of components in all their variations. Furthermore, we also fully automated the creation of these tests. As I mentioned in the previous slides, we have a property explorer mechanism that includes all possible props variations. So we wrote a script that iterates through all of these variations and renders them into the separate page. And we use this page to make a screenshot. With this generation mechanism, we all quickly created over 600 screenshots that test components in all possible variations, considering different themes and different browsers. This significantly helped us with regression and reduced the chance of visual bugs. Also, besides screenshots, we also have integrated tests using Playwright framework. These tests check the functionality of complex components and how they interact with state management utils and other integrations. And the final stage of quality control is our manual tester. Let's move on. And in the end, I want to highlight some of our non-functional requirements, which could be crucial for some of our clients. First one, accessibility. We focus on accessibility and aim for AA levels for our components. Also, we support internalization, allowing any text in our components to be translated into any language. We have right-to-left support. Our components has built in it, and which is important for some of Middle East clients. And we have a mobile adaptability. Most of our components, where it makes sense, are adapted for mobile screen resolution. Um, for example, the body of PQ report opens full screen on mobile devices with mobile optimized UX instead of drop-down on desktop. These features ensure our components are versatile and user-friendly across different environments and user needs. Thank you, and here I pass the microphone back to the Yakov.
Okay, can you switch to my slides, please? Thanks. So at the end, I want to highlight some challenges and lessons learned during UUI development. Some random points. First of all, developers are very demanding customers. Some will be angry that if they are blocked by a missing API before deadline. Some just want something to be done a different way. So you would need to handle this feedback, actually, if you build any kind of reusable code. Designing APIs to last is really hard part. Once we release something, it's hard to change its API. Probably when your customers are far away and you don't care much about the problems, you can build a new UI every year, like React Router does, and somehow they are still alive. But in our case, our customers are just around the corner, and they might have a 2-year-old outdated UI, and now they update it to fix something that it's needed for the release, which is next Friday. Like, and they come to us and they are really angry that the update wasn't going seamlessly. So breaking changes is kind of the thing that probably even harder to do in our case than in like other open source tools where there are no customers right here in the same organization. And like if you design API wrong, and you can miss some opportunities to reuse it to like generalize it later. So we think about APIs a lot before we like publish them. To build a library, you need a lot of skills. Besides just being front-end JD, you need to do a technical writer. You need to communicate a lot to support people. You need to dive into UX deep enough. Then all combination of props of components should work together. When you build component on your project, you care that it works in your cases. But in the library, you can expect user to use all possible combination of everything, even nonsense ones, and you need to gracefully handle these inputs. And moreover, you need to check all these combinations, like both borderless red button with size 54 wasn't we broken it somehow. And the number of this combination can grow extensively. So you can have like combinatory explosions of them. And considering all this, when we see that everything in the library costs like 5 to 10x more compared to in project implementation because of documentation, because it's way more complex to build a library quality component. But even when you build this component, it's just only a start. Then you will need to support it forever, help people to use it, and evolve it somehow without breaking changes. So component is in the library is really more expensive. And we have the rule of thumb. So a new feature should be useful for at least 5 projects to even consider putting it into the library. Then building a library involves making a lot of opinionated decisions. And there will be a lot of arguments. You would need to learn to say no a lot. Even for a very urgent features asked by a level 80 DM, you might want to say no. And extensibility is a key here. What we do is we add an extensibility APIs to help customers to build what they want on their side. And this way we avoid feature bloat on our side. Then you need to evolve into real projects and the real problems. For us, helping projects to overcome the issues not specifically related to UUI helps us to understand and solve real problems better. So you can't do library in kind of vacuum. We also built complex and realistic demos to test how things work together. And probably getting a library with just a demo of separate components is a bad idea because you doesn't check how they work together, how they glue together, how it's easy to do this. Well, in overall, I saw cases when there were many projects for probably the same customer. They all have similar tasks, and there was no reusable library. And this happens often as there is a chicken and egg problem. If you have a single project, you can't afford to build the library right away when starting this project. Then you get the second very similar project, but you still don't have a library and you still don't have a time to build it. This way you can find yourself having a dozen of projects with the copied components with no reuse at all. And even in this situation, when you have a dozen projects, the building a new library won't pay for itself because all these projects use different APIs, they're not compatible, and you can't replace the existing code with the library, or it's at least can be really expensive. So the good idea to overcome this might be to start smaller but sooner, like probably a library with several components or just a package with a custom theme for an existing library would work. For sure, there will be a pushback from developers primarily, which would argument that it's way easier to copy this code to its own repo and tweak it there. So contributing is not easy. Doing features in some other shared library is not easy, and it will be pushback. But gradually, if you will be consistent with this, reuse will grow and investment will start paying for itself. Note that it was not an easy way, at least for us. For us, it took over 10 years. Mm. Okay, to summarize, UI is solid and mature UI library and accelerator. It fits especially well for business applications, as it has many required pieces out of the box. We have a great customization facilities, so you won't get stuck applying customers' brand to it or customizing component as you need. UI is definitely not as popular as ND or MUI, so there is no external community. You can Google solutions on Stack Overflow for UI. But currently, we compensate this with documentation, example, and support from our team. So if you choose UUI, you can expect all kind of support from us. For more information, examples, and quick start guides, visit us at uui.epam.com. You can contact us directly or via Teams or email. And feel free to contact us on any front-end topic, even maybe not UUI related. Okay, that's it. Now let's continue with your questions. Okay. Is it possible to zoom the code a little bit? We will share the deck later somehow in the comments. Sorry for this. As I understand, UUI brings its own data fetching hooks. So does this mean that we should not need use effect as much? Yes, yes. We replace. You can replace a lot of custom use effect based loading mechanism with data sources. That's actually was a goal to not do it manually and at such low level. But you can still use, for example, stack query for some tasks. They works together well. Do UI components comply with modern safety requirements? Well, yes, I believe yes. I'm not super expert in this, but we have a really strong security team and requirements here at the EPAM. And if we does not comply something, we would know. What UI libraries do you follow now? And what solution inspire you when creating new and updating existing components? So there's a long question. I got the idea. Yes, you need to look on the market for sure and look how things are currently done. And we are doing this. We consider our primary like rivals MUI and ND, probably ND way more, because well, we both targeted at this kind of applications where you need complex like input components and stuff like that. But we also look around a lot. There are new libraries arrives, and we try to get as much as insights as possible from them. Probably, yeah, that's it. What interface should support API to work with data sources for table? So we accept a callback which receive some filter, which almost arbitrary objects. It accepts search if you need it. It accepts parent ID if you want tree, and it accepts the range to fetch, either in form, you can use either form of like from and count, so just numeric range, or you can use cursors. Then you can implement this callback as you wish. You can call API, or you can even just generate some random data on the client. So it does not dictate how you implement it. And this means that you can like write and maybe even generic adapter to your backend API standards. That's what usually projects do. So if they have a different forms of filters or paging, they just write a single adapter to the API and then use it. Could you please provide more information on how you export variable updates from Figma? Losha, maybe you can explain a bit.
Yeah, I know that our designers use some built-in plugin, maybe not built-in, like Figma variables, I guess. You can contact us and we will ask our designer. And this plugin provide you to export the JSON of current set of variables from Figma. So then we just export it, upload to our script that also goes through all of these variables and then generate them CSS. So it's basically based by this plugin. if we are talking about export.
Yeah, and we have made an experimental tool to like reapply like three-way diff tool for Figma tokens to reapply changes in Figma forks to like complex stuff. Okay, next question is how do you manage backward compatibility? We just don't break API as much as possible. We have the way to deprecate props, both with TypeScript and runtime warnings. We usually, if you introduce a new props or value, we usually keep supporting the previous one, even if it does not like look great in API. For example, the property cascade selection has option true, implicit, and explicit. And we have this true because it does not have implicit and explicit before. So, but we keep this option to pass true to not break changes. So there is no like silver bullet to this, but we learn to have a lot to just don't break things because it's really, really painful for us. And it's really damage our karma. Okay. What do you use for screenshot regression testing, Lёша?
Yeah, we use Playwright and plus yes, headless Chrome, and also we check the generate the screenshots for WebKit, Firefox. It all of these browsers goes from Docker package from Playwright.
Yeah, and screenshot testing is really great tool for us because we can make them really predictable and they break only when we actually change styles, and we can use them just to diff if we intentionally change style, just to check all combination how all of them changes. It's really the must-have tool. And the generator, well, we after generate all combinations like many combinations of components properties automatically, and it's also help a lot. I'm not sure if screenshot testing would work great for a real business, like real project, because things might change quicker than in library. But in our case, it works great. So there are no more questions.
There is some questions in
Okay.
YouTube tab.
Why did you decide use React for the UUI? Why not other frameworks suitable as Angular? We started with the React, and I don't know. Angular was like when we picked React, Angular was, as I remember, the first version, the first one, and the first one Angular was really ugly, um, especially for complex cases like editable table, and we just straight away want the first interface we built with React is like editable tree with drag and drop stuff like that. And we tried Angular and React will work better. And then we like go with this. Building support like multi-platform library is maybe too expensive for us. We have Angular application in EPAM, actually many of them, but they are not based on UUI code. And we still thinking how to like help them and accelerate them. Unfortunately, it's really expensive to support both. Question: how you implemented them switching in one click? If yes, please share something breezy.
I can
Have
answer.
you implemented? Yeah.
Uh, Because we use CSS variables for our theming, so we just need to connect to your just need to upload another set of CSS variables to your DOM, for example, to the HTML div. So you just change CSS selector, which contains different CSS variables, and them for all components will also change. So it's yes, only in one click.
Yeah, moreover, you can even restyle parts of interface by overriding like variables on certain div, or you can do really fancy stuff with CSS variables. There was times where this wasn't on options, and we see that other libraries historically use like build time theming, like SAS variables, stuff like that. But currently, with current browser, it's CSS variables is just the best way. So probably that's it. Thanks a lot, everyone, for listening. Thanks a lot for asking your questions. Feel free to contact us on anything UUI or not UUI related. And we will be happy if you try UUI for your pet project, or maybe for suggested to use it for your customer's project. Thank you.
Bye.
Goodbye.